Today implementing effect on electric field due to the moving charge particle, or you can say that field produced by a charge particle in uniform motion as well as in accelerated motion. So my name is ZAVED. Okay, I am not drive into the mathematics because I have not so much of time today. So my approach is to analyze the system, then we can relate it. Then after that, I am produce a animated video with what I taught in all this session. So in first, why we need to study this? Why accelerated charge particle or why? So we use microwave oven. Everyone use it. Here is something come that make the food hot. Then we use mobile. Everyone's mobile. There comes some network, some 4G, 3G, 2G, some provider Jio, Airtel. Then we use this TV that where the in the world somewhere is playing some games. Then we see this game in our home. Then here the X-ray, here the some mechanism in medical purpose also. Yeah, some bone break due to some accident or in case then we go to medical. Then the doctor something that enter in our body. Then provide a picture of our breaking the bone. So what the similar things in all the situation in all the picture? It is electromagnetic wave. Nothing but the electromagnetic wave. So the next is my question is how these different types of electromagnetic wave are produced. So how these are produced? We know electromagnetic wave from 12th grade of 12th grade. We are studying about electromagnetic wave, EM wave, Maxwell equation, blah blah. That's wave. How they are born? Electromagnetic wave. How they are born? So this is my question. Okay, for better understanding in this discussion, just we are consider three situations. One is charge at rest, then second is charge move at constant velocity, and third is accelerated charge particle. Okay, so first one is very basic. From our 12th grade, we know our Coulomb's law. We know our field, which is 1 by r square, proportional to 1 by r square. So it is a very basic. When charge is at rest, the field is like surrounding it. Is like circular. Okay, to infinity. This is the very basic thing. Then the second part is charge move at constant velocity. Okay, when charge is at rest, if I got this coordinate here I am the charge and here is the observation point. This is the length of my r vector, and then if charge is at rest, there is no other vector. So, see, only the r vector. Then it is 1 by r square. Okay, now charge is moving. If I consider three vector, then one is charge is at some here, then charge go to here. This is the charge parallel position, and the direction vector where the charge is moving. So this will be like this. Okay, so my point is to calculate the electric field. Okay, for moving charge particle. So for this we are introduced a very good technique, which is potential called linear wizard potential. Okay, using this linear wizard potential, we have V is equal to 1 by 4 by exponent, then some distance r minus r dot b, and these are scalar potential, and below is the vector potential, and this all we are not going to the deep dive in the mathematics. Just I can give an overview of this. If you all are understood the mathematics in later as well. So doing some Maxwell equation and some vector calculus, and since charge is moving at constant velocity, so we put here acceleration is 0. Okay, so there is also accelerated term. In when we all doing some vector calculus, we get finally this result. Also there is an accelerated term, so we put at 0 because charge at constant velocity, acceleration is 0. So finally we come across this equation. That's 1 by 4 pi epsilon q by r. This is the retarded position, and this is beta is nothing but the e by c, which is the velocity of the particle. U by C is the velocity of the particle, and beta and R is the retarded position. So 1 minus beta square plus 0. Okay, now we have to find the charge. We have to find a vector for present position, where the charge is now at some time t, then it moves to at time tr. Okay, so due to this present position, how is the electric field look like? So we need this present vector for that charge. So this I have to change this guy and this guy to RP and theta, and what is the orientation of that present point? So if this is my x-axis, this is charge is looking, this is my RP vector present position, that there this is the theta. That where is the charge in orientation from the direction of charge. So now my task is to introduce these two guys in the terms of RP and theta p. Theta p is the angle between the direction of charge and the present position. Okay, there is some mathematical trick. So as you see, this according to Coulomb formula, all are in same position. There is no velocity, indirect position, present position, all are in same. Then this 1 by r square term this come. Now this is moved, then the green factor will move, and omega t is nothing but the velocity of direction of movement of the charged particle. So theta b, as you see theta b, that observer I just given an I to the observed point. Okay. So do some very little thing, little mathematics over here. Just addition of some triangle law, vector calculus, and then we got this equation. Also, I introduced a space-time interval. Then, with the help of this, we can find this term. This will be this term. Okay. So, and this is just some mathematics, nothing else. Then this and I equal RT. I found out like equation number 4. Then here is the triangle R omega t and RT. Okay, there is a triangle. So with the help of triangle, all three are vector. So area making by area making by two lengths must be equal to the area making by another two lengths. It means I said that if there is a three vector A, B, and C. If I then it makes a triangle, then area making by AB vector is equal to area making by AC vector. So I just use this concept here. Then again try to get some simplification, and finally I got R minus in a retarded position dot B is equal to RP in terms of RP and theta p. It is my task. So finally I got RP and theta p. So here equation number 6. Then we put all this stuff from here to there, and finally put this the original equation. Then I got this equation. Just two simplifications.
So this RR is earlier one when the charge has moved, and RP is now the vector after the charge has moved with a certain velocity, right?
So then we just two things we put here. Again I see these things and these things. I did not do anything with that. These things and these things. Then I finally got to this equation. So thus we got RP and theta p. So so electric field depends on the RP and theta p, where the charge is at position P and angle of how much charge keep reference position or present position keep kept from the where charge is going. Okay, so we are just naming of all this. So you can since moving charge always create a magnetic field, as we know from our 12th standard, and for magnetic field we can have this equation beta into E cross V. And V is nothing but a velocity. I just put for velocity purpose. Thus for a charge moving with a constant velocity, the field depends on RP and theta p only. The electromagnetic field is radially from the present position. I will show everything in animation. Okay, I will show everything in animation and graphical representation. Apart from the I just read. Apart from plot of the field line shows straight line radially from the charge. Okay, let's see. When charge is at rest, means the velocity is 0. Then beta is U by C. So U is 0 means beta is 0. Okay, then it's nothing but a Coulomb's electric field. E is equal to KQ by R square. Okay, so when beta is your sign and this is Coulomb potential. Now we are moved to the kick on the charge. Okay, now beta is 0.3 means 30% of speed of light. 0.3 means 30%. We put the charge in the 30% of speed of light. Then how the field is sensed? The field is compressed in this direction of the propagation of charge. And the electric field is increased in the perpendicular direction of where charge is flowing or charge is going. Now we increase beta or with this not we are changing this. We are not changing the velocity. We are changing the different frame. One frame beta is 30% of the speed of light, and other frame beta is 60% of the speed of light, and so on and so forth. So when beta we apply beta is equal to 60% of the speed of light, then what you see that electric field more and compact and perpendicular direction more electric field is increased in the perpendicular direction. Okay, so if we increase to 80% of the speed of light, then electric field are tends to the Dirac delta function like this, and the direction of motion, and here is the perpendicular direction of electric field direction. So all are incorporated. I just draw this picture for when beta is 0, its field look like circular as the Coulombic potential, and more beta is increased. Field is like this. That change there is change. This you can see the change in this guy, and you can see the height change in height in this guy. Okay, so what we learned that if there is a uniform motion or not accelerated motion, only starts at constant velocity, there is nothing, there is only change in the perpendicular direction of the motion. Okay, so okay, now my point is there any electromagnetic wave radiate? Do you know that if there is electric field, there is either electric field or not? Okay, if there is electric field, I suppose there is some electric field. Is from this electric field, then electromagnetic wave is propagated. Can electromagnetic wave is produced? My answer is no. Why? I am telling you. You can see later. Okay. I just write something that beta is increased, then electric field in the perpendicular direction is increased, and as beta is equal to 0, you can find Coulomb potential, and beta cannot be 1 because no particle move in the speed of light. That's all. Okay. Now how much power radiated? If you calculate the power radiation from that purpose, we need pointing vector. So pointing vector dot dA gives us power radiated from the source or power radiated from the field. If you calculate this pointing vector, surprisingly we will get 0. And put this pointing vector in this equation, and we get some integral convert to special integral. Then this value is 0. So what does it mean? It means that when particle move in a constant velocity, it does not radiate any energy. Okay, it just still like when water is in the pond, just still cool down like this. Okay, so I think there is social electromagnetic. If there is some disturbance, there is some wave propagated. If a steel pond is there, you can throw a stone in the pond, then there is some propagation of energy or propagation of water. So there is no disturbance in the field. Since it has to move at constant velocity, so there is no disturbance, so there is no electromagnetic radiation. So this is electric field at rest. So electric field moving at constant velocity. Now we thanks to the electric charge particle moving in accelerated velocity. So we see the different electromagnetic spectrum for different. These electromagnetic spectrum are come due to radiation due to accelerated charge particle. So why accelerated charge particle produce electromagnetic wave? I will show in the animation video. Okay, so here are some radio wave, infrared light, violet light, X-ray, gamma ray. Do you know all these waves can be produced by one single charge? Just depend on the acceleration. If we give more acceleration, more energy charge produced. If we give less acceleration, less energy electromagnetic field produced by one single charge. So this all stuff depends on the acceleration. If acceleration is more, there is more energy in the electromagnetic wave. If acceleration is less energy in the electromagnetic wave. So this formula is nothing but the Lamor's formula. So what does Lamor's formula tells us? Lemma's formula is nothing but a proportional to acceleration square. If there is more acceleration, more power radiated. If acceleration is zero, no power radiated. If less acceleration, less power radiated. It means less power means radio waves, more power means gamma wave. So this is all about just accelerating wave. Now I show you a video. I will show you a video. What I talk, I will show you a video. Okay. Okay. Let's see a video animation. Ma'am.
Just
Okay.
it's working. Otherwise, if the
Okay, ma'am.
it's not installed, then
It's coming.
the driver and all.
So we see different kind of electromagnetic field here. One is fluctuating electromagnetic field. I am not talking about the fluctuating electromagnetic field. I am talking about the propagating electromagnetic field. That one point to the other one. Okay. I am talking about this electromagnetic field. Okay, you can see. I am talking about this. Here, now discussing about the fluctuating electromagnetic field. Okay, here is such particle at rest. It is moving in a constant velocity. Okay, so constant speed. So there is no sense in electromagnetic field. Since I am not changing my velocity or not changing my frame, so there is no sense. Now this particle is accelerated. Now this particle is accelerated. Okay, what happened with the electric field? Now you see. Okay, when then I just slow down the picture. Then this particle is now accelerated. Okay. So how does electric field is made? Okay, there is a point that when such particle is accelerated, try to accelerate, then this is the old electric field. This is old electric field and this is the new electric field. So there must be some kink or some disturbance. When I got here, just someone would look that I have disturbed my position. There must be some kink or some disturbance. If I am moving like a constant velocity, there is no disturbance. If someone kick me, then I feel there is disturbance. So this is a disturbance, and this disturbance leads to the emit of electromagnetic wave. And this disturbance that come out and we can call this is electromagnetic wave. Now see. See, this is old field and this is the new field, and this portion is disturbance. Okay. Since electromagnetic field is always continuous, it cannot break. So thus I can draw this kink. Okay, there is a kink. I show the disturbance. And how this disturbance will propagate, you see later. Thus this disturbance is propagated and electromagnetic field going like this. And how this disturbance is propagated? See, this disturbance is propagated outward to the outward. This is the propagation of disturbance. It means this is the propagation of electromagnetic field. Sorry, electromagnetic wave. Okay. We will see or more. Okay, now we consider a dipole. Very simple system. Now we consider, since it is all about acceleration, nothing else. So we consider a dipole. Okay. One position and one negative, continuously accelerated and decelerating. So if this is accelerating and decelerating, there must be some electron. They must be emit some electromagnetic wave. So we can see this how they emit electromagnetic wave. Okay, this is dipole, and they continuously accelerated and deaccelerated. So this will be the effect of dipole and produce of electromagnetic field. How this field produced, we will see. How this effect are produced, we will see. Okay. Hence, these dipoles are accelerated and deaccelerated. At top it is 0, and at bottom and middle one it is maximum. From simple harmonic motion. Continuously accelerated, and we know that if it is raised, then the electric field will look like this. So let us consider just one line. Just one line. So how does line will propagate? This will be propagated. Okay, just one line. Okay. Now how does when it close to someone? This is the this is the actual field and this is the new field. Some disturbance here. Some kink is produced in here. Okay, this is kink. Some disturbance, nothing but this is nothing but a disturbance.
Now they are at that time the velocity is maximum. This is the velocity maximum position. And now at that bomb the emit of electromagnetic wave. This is how electromagnetic wave are emit. So I just try to describe how electromagnetic wave are emit and how Lamor's formula are used to predict how Lamor's formula are differentiate the different kind of electromagnetic wave. It's all about you don't think that only accelerated charged particle can emit electromagnetic wave or like gamma ray, beta ray. There are many processes like in nuclear physics, and when electron exceed from one energy level to another energy level, then there will be some emission of electromagnetic wave. Just I show one of these process to explain how basically the electromagnetic wave is propagated, how they detach from the electric field and propagate to the vacuum. So this is all about my presentation.